So today we will be dealing with disk fragmentation. So on day 9 we are given a disk map, which is a long string of numbers, and the numbers indicate files and free space on a disk. So it alternates between the numbers, between the digits, and it first goes with length of a file and then length of a free space. So a string like this has 3 files, a file with with length of 1, then file with length of 3, and the file with length of 5, and in between that are 3 spaces, and one is long 2 blocks and the second is long 4 blocks. So it's kind of alternating, and then we also are given ID numbers based on the order of files. So the first file in order or in the disk map has ID of 0, then the second file has ID of 1, and so on. And if you visualize it, you get something like this, where the example 1, 2, 3, 4, 5 looks like this. You have the first file has ID of 0, then you have 2 free spaces, then a 3 block file of ID 1, and 4 empty spaces, and 5 block long file with ID 2. So based on this, we get some kind of visualization for this example, and our goal is to then defragment the disk. So we need to move file blocks one at a time from the end of the disk to the leftmost free space block. So we need to do this until we are out of space, basically. So we get the initial input, then we start moving the file blocks to the left to empty spaces. So overall, we kind of move around parts of the file until we have everything in one continuous block of content. So finally, we need to update the file system checksum, and the file system checksum is multiplying the file ID with the position. So the first position is 0, and we kind of multiply the number. So 0 by 0 is 0, then first position by 0, then the second position by 9, and so on. And we kind of sum all those multiplications and we get the final result. So let's try to solve this one, yeah? So I will switch to my my app, and then I will also take the sample input. So this is the sample input that they are showing here. So I'll put it in test data, and now we will read it. So in the disk map will be await input reader, read line async. And now what we do is we will kind of build our understanding on where files are, where spaces are. So I think we could track we could create some kind of helpful records for that. So public record file block. So it's gonna be file ID, start, end. So start a length, and then we could have something like this. I'm not sure how we'll use it yet, but let's try to kind of read it in. So we'll have disk map length, and is file true. So the first index is file, and the second will be false. It's going to be free space. So if is file, then the ID will be file ID will be I divided by 2. So the first position will be 0, and yeah, so it should be like this, and then the big start of the file. So our current position, so it's going to be 0. So our start will be current position, and the length will be yeah, exactly. It's going to be the value of the character. So this should be the size of the file. Okay, so now we read in the file, and we will track the files in some kind of list. Files, and we will add the new file block, and that's basically it. Now so we get the files, and we also need to track the free spaces. So for free spaces, we just get we always extend it by length, so we can do that by like this, and our current start equals current position, and we get also free space. So like this. So we could just add new free block, start and length. So this way we should be reading in the contents correctly, and we can actually confirm it by going through we can actually confirm it by just building out the string builder output, and we can do output append string repeat string id to string with length. So it's going to be 0, and the same here we will be doing, but dot. So there I'll just try to see if I'm building the input correctly, because that's important. So I'll just run this as it is. Let's see, yeah, it's this one, and I'm not, so it's important. Yeah, so of course, very, very basic mistake. So we need to not false it, but do not file this file. We just invert it. That's the way to go. So yeah, that's it. Let's confirm. It should be looking just as it's supposed to. Yes, that's pretty good. Okay, so reading in the test data is okay now. So that's pretty good. And now we try to move the disk blocks into the free space. So while we have any free space, and we take first space from the from it, then we will try to push in the file blocks from the right as long as possible. So while, well, let's see. We will just take the file blocks and try to, take the remaining space, and we will, while remaining space is greater than 0, we will be doing so for so we will be doing, we'll need to, that's important, we need to make sure that we don't incorrectly take the files that are no longer reuse the updated files. We don't want to update files that we already moved, so we'll have moved files. That's going to be the files that we have moved somehow. So we will be taking all right, another. Yes, so we'll move the minimum of the remaining space and the last file that we have. So we either move the whole file or we move just part of it that fits into the remaining space in the first free space that we have there. So moved file is going to be a new file block that we move. That's exactly it. So the same ID as the last file. We will move it to the start of the first space, and we will move the length that we are given. And now we add it to moved file. We need to update the last file. So if to move equals last file length, then we remove that file, and otherwise we just update it. Yes, exactly. So we update it to have length of, well, we keep this as it is. So the start of it is the same, but we will move part of it away. So now this remains, and we are continuing with the next part, and we need to make sure that we update the remaining space by this variable. So I think that's enough to make it work. And then we'll continue, make sure that we take the first space, and yeah, okay, so if and files any. So if there is a remaining space, and there are actually some files that we can move, because if you moved everything, it shouldn't happen ever. But just to make sure, we just make this check additionally. And then if the remaining space is 0, well, we probably pulled in the space, pulled in the files. Oh, one important thing that we need to check. Yes. That we don't need this check, but we need to make sure that if first space start is greater than files last start, because if the space begins after the file itself, then that doesn't make any sense to move anything, and we just break. So this is where we stop moving if we run out of all the free space. Yeah, I think that makes sense. And essentially, as I'm looking at it now, we don't need the list. We are okay with just a queue, because we will be dequeuing. So it's first in, first out, and we will be queuing the free space as we go. So now we will be dequeuing the space. So dequeue. And if we hit a space that is after the last file, then we are done. And otherwise, we just move the files and we dequeue the free space, because we'll fill it always in this loop. So that should be okay, I think. All right, so we have this, we process it, and then we have to calculate the total sum. So now we'll merge the files. So files, append moved files, and we need to make sure that we kind of merge them together. Which we, append is not the one. I need concat, right? Moved files, and we order them by f start, and we just put it into a list. That's fine. So all files, and then we calculate the result. So our total sum will be 0, and we will be going for in all files length count, and we will be calculating the total sum. So file all files. Actually, we didn't have to even order anything, I think, but it's fine. A total sum. So and I will do so for length block ID equals 0, and it's gonna be file length, or actually, yeah, it's fine. Block ID. I will be doing something like current position equals file start plus block ID, and total sum will be, yes, this file disk position will be start plus block ID and multiplied by ID, and this should be enough. Now return this to string and we'll see if this worked or not. $5,754, that's quite a big number. That seems unlikely. So let's see what happens there. This data, we'll have 14 files. So 0, 0, then 2 9s, 2 8s, 2 8s. No, 8, 1 8, then 3 1s. Yes. And 3 8s. Yes. It seems so far pretty good, but I'm probably just calculating stuff incorrectly there. So let's verify. So starting on, so the initial position should be oh, that's wrong. I'm using the wrong variable there. Ha! Classic mistake there. Yeah, so I was using current position, which was actually variable from before, which meant I was completely wrong there, but it's still not completely correct. So let's verify the end of the list. Seems I made some mistake during the moving of the files now. So the end is 6, 1, 2 6s at the end, and so on. Okay, that is, so there is 6 there, 6, 1 6 2 6s 3 4 2. Okay, this is interesting. I see. I made a mistake here when adjusting the free space, because I was moving the file to the start of the first of the space itself. It should be not to the start of it, but to start minus the space that we already filled. So empty space start or current start. So it's gonna be first space start. And now we need to make sure that when we move something to the start, we actually also update the start, the move. So by the moved length of the file, we have to move our pointer to the beginning of the updated free space. So now I think that should be better. Now we should be updating it more correctly. And yeah, I think that is right. Okay, so let's see what it says about my full puzzle input. So put it there and then pick the input file. Okay, so we're overflowing some kind of number there. So what I will do is just put the total sum be long instead of int. And that seems better. And that is correct. Okay, so we have the first part solved. On to the second one. In the second part, we are going to be moving the files to the leftmost span of free space that could fit the file. So instead of moving the files block by block, we are moving the files as to the first space that it fits, that fits the whole file. We are attempting to move the file exactly 1 in order of decreasing file ID number, starting with the file with the highest file ID number. And if there is no free space to the left of the file that is large enough to fit it, then the file doesn't move. So hopefully this could be just about adjusting our logic there, the moving logic, in a way that handles this adjustment that we are moving just the largest file. So now, well, we will not actually do it this way. We'll do a free list, free space, like this. And we will be adding that there. And now we cannot actually process it until the end, until the free space count is greater than 0, but we will have to do it in a different way. So for file dex, so files count will be starting from file end, so files count -1. It will be going greater than equal to 0. File index minus. So file to move. And we'll try to find the first empty space that fits it. So when we find that space, we'll have to replace it by a smaller space that remains after putting in the file. So for free space index, free space count, we will be seeing if the file fits. So if a file to move length is greater less than 0 or equal to free space at the that free space, free block length, if it fits there, let's remove that and try to think of it ourselves. So if it fits, then we will move it there. So move file, and yeah, so it's gonna be a new file block with the same file ID. So if file to move ID, move ID, then it's gonna be starting at the start of the free block, and it's gonna be the length of the file. Oh yeah, there was free block started. I will just let it completely output. We'll add a moved file to, well, we don't have to now track the moved files because we are just processing it from the end. So anyway, we can just remove that. And well, although, right, we should track it. We need to track it anyway. We need to remove the file from the list in all cases. So, and we need to move the file from how to move. Yes, that should be okay. We need to actually always move the file even if we are not able to find a space for it. So and if we find this free space found equals true. So in this case, we found a free space for this file, and we need to also, yes, decrease the free space by the size that we moved. So that seems okay. So we we move that free space to start plus length of the file that we moved, plus we decrease the size. And this could be 0 even, but that is not a problem, because if it's 0, we'll never fit any file in it. We'll just process it. But this, by keeping that free block there, even if it's 0, it means that we don't have to resize the free space list, which is more efficient in terms of space. We don't have to resize in terms of performance, because we don't have to resize that list and remove that item from it. So it's just going to be probably faster than to let our code process it while going through the free spaces. We just skip it because it's going to be empty, and we will not be able to fit any files in it. So if we found the file, if no free space was found, we just put it into moved files anyway. So it wasn't actually moved, but we can move it. We can move it, or we can just actually we can just, well, we'll be processing all the files, right? So those which are moved, we will be removing from the list. So files remove at file index. That should be okay, right? So we remove the files if we move it. Otherwise, we keep it in the file list, so we can keep the same logic as we had before there. So we can keep the same logic for the concatenation and calculation there. So that's good. The only thing that remains is that we need to make sure that we don't move the file to a location that's after its original location. So if file to move, oh, actually, that's pretty interesting. When we move a file, can we create a new space for? No, because we are going from the right. So if we create a new space for a file, it no longer matters, because if we move, in this example, they move 777 here, but they no longer move 888 into the newly created space, or even here, it would fit there, but it's processing just once. And if it doesn't, there is no space there, the file never moves. So we don't have to check it. We need to make sure just to never move it to a location that's further to the right of the file. So free block start. So if it fits into the size and the free block actually starts before the file, that should be okay, I think. Sure, we can get rid of this variable anyway. We don't need it. So now let's try this data. It's 285 58. And with the main input file, it's this number, which is correct. Okay, so we have both parts solved. This one was more complex, or at least more confusing to think about because of the file IDs versus positions versus sizes and stars and so on. So it was a little bit more confusing, I think. But in the end, it worked out well. So I'm pretty happy with this. And I will be doing also another video, as usual, to see if ChatGPT can actually solve this problem as well or not. So stay tuned for that video, and I will see you on day 9 or day 10 actually. Right. See you then.